Here we go. So yes, hey guys, hi, teacher.
1,000 was done.
Okay. Yesterday I forgot a piece of our notes, which I realized last night while I was grading, and I was like, oh no. So we're gonna have to do a little pause and insert, because I forgot the beginning part of polynomials. I skipped it. So I was supposed to do this before we did what we did yesterday, and I did it. So no, that's not why I did it. No, nice try. But this is just our overall view of what a polynomial is. And so yesterday we talked about that a polynomial are power functions just added together, right? And so I just wanted to reiterate what a power function is. So a power function is when you have a function, the constant, and just the power. Hence why it's called a power function. Okay, so we're gonna talk about the even power function and an odd power function and their behaviors and how they act. Cool? All right, so first up is our even power function. So even power function means that our power is going to be an even number. Our even numbers are 2, 4, 6, 8. Who do we appreciate? Okay, just keeps going, right? All right, so that's what that is. All right, the function then therefore would look like it would be x to the 2 or x to the 4 or x to the 6, etc., etc., right? All right, so if you look here at our graphs, we have an example of each one. So the outside graph, this parabola right here, this is f of x equals x squared. Looks familiar? Okay, the closer it gets in, the inside parabola here, this is x to the 4. The closer I get in is going to be x to the 6. So when we're looking at them, it says as for x less than or equal to -1 or x greater than 1, the graph is doing what? As our exponents are increasing, as our powers are increasing, what's happening? They're getting smaller, they're narrower. They're getting narrower? More narrow? What's the English word?
More narrow.
Wait, no. The graph narrows. Narrows.
Yeah.
Right? Narrows. Yeah. The graph narrows. Yeah. Don't make me vanilla. Vanilla. All right, here we go. As n increases, do we see that? Yes. All right. And can someone tell me why it's getting narrow?
Because it's getting steeper.
It's getting steeper, which means that what's happening with the numbers? They're doing what? The y values are increasing faster, right? They're increasing at a faster rate, which is why it's getting steeper. So they're getting closer and closer to the x-axis. All right. Now, if we look in the middle right here, what do you notice is happening here at the middle? Remember, our parabola was kind of curvaceous, curvular. I don't know. Curve. Let's just stick to the curve. And then as it's getting in, it's flattening out. So the graph flattens. It's going to flatten around 0. 0. As n increases. So it's going to keep getting a little flatter and flatter as n increases. Okay, in behavior. So we talked about in behavior before and types of symmetry. With an even function, in this case, what type of symmetry does it have?
What is that?
Even symmetry. It has even symmetry, which means that they're going to be doing the same behavior. So our n, when we're looking at the graph, as our x's forever goes to negative infinity and forever go to positive infinity, what are our y values doing? They're increasing forever to positive infinity, right? So our in behavior is going to be
Infinity.
Infinity. F of x goes to infinity. Okay? And for even functions, they're going to do the even behaviors. Okay? You're going to start how you end. So, yeah. I guess. I don't know why I grew with that so quickly. It's all right. You know, this is raw. Raw footage. Here we go. Yep. Power function and odd. So now, what if n is odd? Okay, so our odd numbers are 3, 5, 7, 9, etc. Okay, there isn't a cool one that goes with that, so just end it like that. All right. No, there isn't. Don't force it. So the function would look like x to the third, x to the fifth, x to the seventh, etc. Right? And look right here. Oh my gosh, they're drawn out for us. Okay. So when we look over here, the outermost is our x to the third, inner is our x to the, and then the very close to the inside is x to the seventh. What do you notice about the function as it's getting? It has odd symmetry. Anyone remember what that odd symmetry is called? Anyone remembers? Origin. It's called origin symmetry. Okay. Rotational symmetry. Good job. It has that origin rotational symmetry. Okay. And so here, again, what do you notice happen to the graph as our powers increase? It narrows. And what do you notice is happening around 0? It flattens. As n increases. Now, let's talk about the end behavior. So on the left-hand side, as x goes towards negative infinity, where are our y values heading? They're heading towards negative infinity. On the right-hand side, as our x values head towards positive infinity, where are our y values heading? Positive infinity, okay?
Can you write that again?
The infinity symbol? Like literally write it?
I don't know how to do it without turning it.
Yeah, that's what I was thinking.
All right, so odd functions are going to have opposite behaviors. Does that make sense? Odd functions are going to have opposite behaviors. Even functions are going to have even behaviors. Got it?
Yeah.
All right. That's what we forgot to do before we started yesterday. Okay. So we made it up. Here we go. So now on to the rest of our notes. So yesterday we talked about our classifying whether something is a polynomial, right? And identifying its degree and the number of terms and all that good stuff, right? Okay, today we're going to be looking at polynomials in factored form and using our previous knowledge to find the roots and to expand the function to determine its degree. Okay, have we found roots before?
Yes.
Yes, we have. Have we multiplied before?
No.
Yes, we have.
Yes.
We have multiplied before using FOIL, so, and other things, but we've multiplied. So these are skills that you already have. Got it? All right. Yeah, you do. So in factored form for a polynomial, it's going to look like f of x equals a parentheses x minus r1, x minus r2, x minus r3, etc., etc. Depending on the degree of the function, it can have a certain amount of number of factors. Does that make sense?
Yeah.
So depending on the degree of the function, the number of factors you have is going to change. All right. All right. So here we go. We're going to talk about finding roots and determining and expanding and determining the degree. So first thing first is when you have a factor, to find a root, the root equals your x minus r equal to 0, right? That's what you're looking for. So when I look here, I have my factors, x minus 2 and x plus 3. To find the roots, I'm going to set each factor equal to 0. Okay, then we have x plus 3 equals 0, and that's going to give us x equals -3. Does that feel familiar? Yeah, we're good? So that's how we find our roots, once it's already in factored form. Now we're going to talk about finding our degree and expanding. So when we are expanding, putting it in standard polynomial, that means we're going to multiply. And the algorithm that we use to multiply this is called FOIL, right? If you do not like FOIL, what is your other option? The box, right? If you're not a FOIL person, you have the box. I'm not really a box person, but if that is your thing, then do it. I like FOIL. Because that's what I did from 8th grade until I got to college. And said, you gotta teach students this too.
But it's not easy.
What?
Yeah.
Okay, so everyone, whatever method you want to, expand the factors. So I'm doing FOIL. First, outside, inside, and last. So my expanded function equals x squared plus x minus 6.
Oh, okay, I get it.
Okay. Okay, so then what's the degree of my function? The degree is 2. So this is a second degree polynomial, which we knew. Okay. So then for on the computer. So questions, comments, concerns so far? Doable?
Easy.
Maybe.
I get it.
Are these skills that we already have?
Yes.
Yes. We did not make up any or add any additional skills. So what I would like for you to do is to do number 10, and we're gonna see what you do with number 10. All right, guys, let's check and see what you should have done and tried. Guys, shutting down and not doing isn't going to help you at all. You have to try. Persevere. Okay? I said what I said. Here we go. So when you have x on the outside, that's basically saying that you have x minus 0, right? That x on the outside. So therefore, your roots should have been x equals 0. And x minus 4 equals 0 means x equals 4. You had to find your roots.
That's what I was asking.
I didn't know. You said solve. I didn't solve. See, those aren't the same questions, though. To solve and to find roots are not the same thing. That to solve means I'm taking the equation and setting it equal to something. I did not take the entire equation and set it equal to anything. Just saying. So vocabulary is important. All right, so roots are done. Questions about the roots? All right, next was where you're going to expand it and determine the degree. Okay, so expanding this, the power tells me that I have 2 of these. I have x minus 4 times x minus 4. How you distribute is up to you. You can FOIL first, you can distribute the x first, and then FOIL. It does not matter as long as you get through the multiplication, okay? I'm going to FOIL first, so I'm gonna get x squared minus 8x plus 16 after FOILing. So all I did was the FOIL algorithm. And now I'm going to distribute. After I distribute, I have my function f of x equals x to the third minus 8x squared plus 16x would be my expanded polynomial. And this is a third degree polynomial.
Why is it,
Why does
oh, okay, you distributed the x. Okay, never mind, I get it.
Yes, you have to distribute the x. Why is the what? You sure? Okay.
You have the same question I did?
Yeah.
What was your question?
I was just waiting.
Oh,
Okay. I'm going to let you try 11. So we're going to pause again.
thank you.
You're going to do 11. All right, here we go. So first off, your root. What is your root?
3.
2.
2. Oh, bad, I meant 2.
It's only 2. Your root is x minus 2 equals 0 because that's the only factor you have. So x equals 2.
Why not -1?
Negative 1 doesn't have a variable attached to it. That's just your a.
Okay.
Okay? There's no variable attached to it. All right, so root's done. Now we're gonna talk about expanding. So to expand this 3 means I have x minus 2 times x minus 2 times x minus 2, right? I like to do things in pairs, so I typically would distribute the negative and then FOIL the last 2. I don't know why, that's just how my brain works. So if you are a person who needs to see the box method, I will do that as well.
Thank you.
So for the box people, let me at least distribute this first. So that's going to give me negative x plus 2. And I will use the box instead of FOIL really quick for you. So x minus 2 times x minus 2 gives me x squared minus 2x minus 2x plus 4.
X minus 2. X
And that gives me x squared minus 4x plus 4.
Still must be.
What
Can you, I'm using to do a snip check on you.
were you talking?
All right. All right. So did seeing the box help for anyone that was
Why does it
all right? Shh, guys. Hey. All right. So 1 through here, we then are going to you have to either multi-distribute again or create a bigger box. So if you chose to do the box method again, this time you would have a 2 by 3 box. And the reason why is because you have a binomial times a trinomial.
This is whenever I wanted to.
Either way. So now you're going to multiply negative x times x squared is negative x cubed. Negative x times negative 4x is positive 4x squared. Negative x times 4 is negative 4x. 2 times x squared is 2x squared. 2 times negative 4x is negative 8x. And 2 times 4 is 8. So then your function f of x equals negative x cubed. We have 6x squared. We have negative 12x and 8.
Did you do the FOIL one? See how you do that one? You get this one?
Yeah.
Wait, Miss Jones, are you multiplying or adding the box?
Once you're done and everything's filled in, you combine like terms.
What the, what?
Oh, no.
There's 10 into bubbles. What?
I like that.
No.
Okay. So if you wanted to see it as a FOIL, then I would do negative x cubed, positive 4x squared, negative 4x, 2x squared, negative 8x, positive 8, and I'm going to end up with negative x cubed plus 6x squared minus 12x plus 8. Same thing.
Oh yeah, that box is good. It do look good. That box is good. It do look good.
Miss Jones, we need some bigger notes. I don't know.
Well, you didn't have to write both examples. I just modeled both. People ask, but
Thank you.
I left the box down there on accident. It didn't come with it.
Let's see rates it on.
I was trying to bring the box back and it came in pieces.
Let's see rates it.
There we go. Nope, I'm not a quitter.
You are missing the number.
I can fill it in. All right, so either method is your choice, right? So whether you're gonna do the multiple distribution or you're gonna do the box method, are we gonna result in the same thing? Yes, okay? So that is what you're doing. Again, skills you already have. You just need to use them. All right, last one for you to try.
Oh no.
There's another one.
Oh no.
Here-
Oh no.
All right, so you have f of x equals negative, oh, what degree was that? Third degree, right? Four terms, third degree. All right, here we go. You have negative x squared times 4 minus x squared. Pick your poison and solve. All right, what are your zeros? What are your roots?
4.
Remember, this is like x minus 0.
Why is it 0?
Is there anything being added or subtracted to this x? So why do you want it to be a 1?
That's what you told us. You said-
I did not tell you.
That's for multiplying.
One.
Subtracting.
That's what's good in algebra too.
What?
Yeah, that's what you told us.
No,
I thought it was weird too. But you said
I don't know what you just said.
Yeah, you said that, Ms. Johnson.
Alden, you barely remember yesterday. Now. So when you're adding, it's a 0. There's nothing there. You're adding a 0. When it's multiplying and there's nothing there, then it's a 1. But this is an addition. This right here, this is a 1, but this is for a. That's a is -1. Your factor, there is nothing there. Like, in order for it to be equal to 1, it would have to say x minus 1. And does this say x minus 1? No. So my root can't be 1 if the factor isn't x minus 1. Okay? So my root, and we just did it, if we go back really quick. And what did we say when the x was by itself? It was 0, right? Okay, so the same thing is still going to apply, even if you add a power to it. Okay? So your x equals 0, and what is your other x? 4. What else does there acknowledge? We've already did. No. Really, Hira? Was that necessary? Exactly. I just told you, I watched the video for 5 times and look what happened to me. So don't say you didn't get warned. All right. Deaja's gonna walk us through.
Okay.
Well, come write it. You guys just struggle writing up here. There's a pen right there. Go write. She said she wants to write.
Yes,
All right, Deaja, what do I do first? Foil. So I'm gonna foil. And I get negative x squared. And we get x squared minus 8x plus 16. Then what do I do? Then I distribute. So we get negative x to the 4 plus 8x cubed minus, you saw that? Minus 16x squared.
That's what I got.
That's what you should have gotten. Good job. And so this is a 4th degree polynomial.
A quadrate.
A quartic.
Yeah.
Quartic. All right. All right.
Can you do that again?
No, I cannot do that again. I was just literally leaning back to see what time this class ended, and life flashed before my mind. I was leaning back on my chair.
No. Long version.
Cut it. It's not. Oh my God, we got to fix it out. Oh my gosh. All right. We're on the last part of today's notes and we're gonna get through them. All right, the graphs of polynomials are smooth and continuous, right? There's no gaps, no breaks, no holes, no sharp turns, no asymptotes, none of that. Okay. The domain is all real numbers because it goes from negative infinity to positive infinity. And your end behavior depends on what the degree of your function is, right? So if my degree is even, then it's going to be even behaviors. If my degree is odd, then it's going to be odd behaviors, okay? All right, a polynomial of degree n has at most n roots, okay? So you're going to have at most, if I have a 2nd degree polynomial, aka a quadratic, we can have either 2, 1, or 0 roots, right? If I have a cubic, a 3rd degree polynomial, we can have 3, 2, 1, or 0, okay? All right, we're going to describe are y'all done? The root behavior. People Paul, get over it. We're gonna So we're gonna describe the root behavior. So it's a single root. A single root means that when you write your factor has a power of 1, aka Casper the friendly 1. So if I have x minus r to the 1, am I gonna see the 1 as a power? No, because it's redundant. So an example would be if we had x minus 2 and x minus 4, right? These are single roots. Why? Because what are the powers on them? 1. So graphically, what's going to happen is your graph is going to cross at those roots, right? It crosses at 2 and it crosses at 4. That's what happens with a single root. It's going to cross. Okay, now we're going to talk about double root. A double root means that your factor has a power of 2. And an example, and it's not just 2, it's just multiples of 2. So if I have a factor multiple of 2, then I have a double root. So 2, 4, 6, 8, 10, all those. All right, example would be if we had x minus 2 squared, right? X minus 2 squared, what happens in this situation is it doesn't cross the x-axis, it touches the x-axis. Okay, it's going to sit on the x-axis or sit below the x-axis, but it's going to touch at that point.
What? Oh.
And again, double root applies to all multiples of 2. Okay, triple root. So if you have a triple root means that you're at x minus r to the 3rd. So for example, if we had x minus 2 to the 3rd, what this is saying is that typically you're going to have the same behavior as a single root because it has the same odd properties, but your other roots are probably imaginary. So notice here, I'm going to go through 2, but I'm not going to cross back again because I only have that one root. So the rest of my roots are imaginary. Okay, that is why the exponent of your power of your factor is important. All right, we call this multiplicity.
All of that is what that's called?
Multiplicity. So it's the multiplicity of your root. All right, and that concludes our notes for today. Tomorrow we're going to get into graphing from factored form and standard form.